Here we're going to learn how to find the shortest path from one node to another. So this example, we're finding the shortest path from A to E. We can travel along as many edges as we need to, but we want to collect up the least amount of weight to get from one place to another. The method that we're using is Dijkstra's algorithm. The first step is to start by labeling the beginning node. So we are beginning at A, and we're going to give that a label of 0 because we haven't covered any distance yet. The next step is to use the weights along our edges to label neighbouring nodes. Now these are our neighbouring nodes. I go along that edge. I travelled a weight of 1, so I put a 1 there. Draw an arrow going back to where you have just come from. And I've also got another neighbouring node. Along this edge I had to travel 6. So I pop a 6 there and an arrow back to our the node we came from. Those are all the edges connected to A, so I can cross that one out. My next step is to select the lowest value node. Now 0 is our lowest value node that we've labelled at A, but we've already covered A. So what's our next lowest? 1 at C or 6 at B? 1 at C is lower. So that's my next node. I need to use the weights of the unused edges to label the neighbouring nodes of C. So this is an edge that I'm going to use. I started with 1 at C and I travelled another 1, so now I am 2 when I end up at D, and I'm doing an arrow back where I came from. This other edge here is free. If I travel along that edge, this extra note here, replace an existing label if it will create a lower value. Now I started at 1 at C, and if I add on 2, I would get 3. Now 3 is a lower value than 6, so I'm going to cross out that 6, and I'm just going to cross out that edge. That's where I got the 6 from, but that's not going to give me the shortest path, so I'm crossing that out. And I need to put an arrow back where I have just come from to get 3 at B. Those are all my edges coming out of C, so I'm done with C. What I now need to do is I'm repeating these 2 steps. So select the lowest value node. I've got 2 at D, so I'm going to go for D. This edge here, if I draw that one, 2 plus this 5 is going to give me 7, an arrow back to where I've just come from. And this edge here, if I go along that one, 2 plus 2 would get me 4. Now 4 is not smaller than the 3, so I'm not even going to put that there, and that's why I've covered this edge in red, because that's not going to help me get the shortest path. Checking back at D, those are all the edges coming out of it, so I'm done with D. And again, select the lowest value node. I've got 3 at B, and I've just got one edge to check here, but I can see the 3, and if I add on 5, I would get 8. That's not smaller than 7, so I'm not going to worry about that 8. And I'm going to draw that edge in red. There's no more edges coming out of B, so that one is done. My lowest value node, well, that's only one left now, and that is 7 at E. And that is going to give me the weight of the shortest path. So we can retrace. We're at the end. We wanted to get from A to E. We're at E now, so I can go back along following the arrows that I've drawn. I'm not going to go along here because that arrow is stopping me. I'm wanting to go back that way, so I'm not drawing that edge. This is the edge that would take me back to A. So my shortest path, I can see it there in yellow, A to C to D to E, and we can just check the weight, the total weight of that again. My first edge here was 1, and then another 1 from C to D, and then 5 from D to E, and that should match up to the